So today I'm going to be doing a container with the most water, which is question 11 on LeetCode. So the question is, you are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I0 and I high I. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. So in this example, the input height is an array of numbers 1, 8, 6, 2, 5, 4, 8, 3, 7. And the output is 49 because the above vertical lines are represented by an array. So 1, 8, 6, 2, 3, 5, 4, 8, 3, 7. In this case, the max area of the water blue section the container can contain is 49. This is because the distance between number 8, which is an index of 1, is 1, 2, 3, 4, 5, 6, 7 wide from the second highest, from the 7, which is index of length minus 1. So 7 times the lowest, because you can't overflow, 7 would be 49. And although this one may look like it contains most water, it's 2 less width and 1 less height, so it would be less. Example 2, height 1, 1, output 1. Okay, so there's two ways of doing this, and the first one is a brute force method, which pretty much we loop through the array. We loop through the array twice. We get the first I value, and then we go again and get a height value, and then we set the max every time we loop through the j to either the current max or the max width. So let me give you an example here. Okay, so let's say we're given the array. What was the array again? It was 1, 8, 6, 2, 5, 4, 8, 3, 7. 1, 8, 6, 2. Let's just say 1, 8, 6, 2, 3, 8, 3, 8, 3, 7. Whatever, something like that. Okay, so the first thing we're going to do is loop through the array once. But we first have to create a variable max, which we set to as 0. Then we loop through the array once, with I being 0 at first, and j will be 1, I plus 1. So let's loop through the array first. First we have I, 1. So I is 1. And then we loop through the array 8. So I plus 1, the first one will be 8. So 1 times 8 is 8. We check the max, 0 is bigger than 8. So we say it as 8. Sorry, j is not 8, j is 1. Now j is 2. 1 times 6. Oh, sorry, this is not 8, my bad. 1 times 8 is we take the minimum 1 times, so the distance is 1 and the height is 8, so that would be 1. Then on j is 2, 6. So the width is now 2, because it's an index 2 minus 0. I is 0, sorry, not 1. 2 minus 0 will be distance is 2 times the smallest one between I and j, which is 1. So now 1 would be 2. And then we go to j equals 3, which is 2 again. So the max width would be 3, because now the distance between I is 3 times 1, which is the smallest. Then we go to 4. Again, it will be 1. Anyway, all the way up until the end, it will be 1. So we just skip the rest for this I loop for now. Then we go to I equals 1, which will be 8. So now, j is I plus 1, which is 2. Oh. So now we're on 8. Use a red marker, 8. So now the max is either between 8 and j is 6. So it will be 1, because this is 1, times the smallest, which is 6. So the max would be 6. Now, we go to the next one for j, which is 3. and 3 is 2, so the max will be, so 2 times 2 is the minimum of 4, so we don't increment the max. Now j is 4, which is 3, distance is 3, 3 times 3 is 9, which is bigger than max, we set the max as 9. Now j is 5, the distance is 4, and the lowest, so 5 is now 8, index 5 is 8, so 8 times 8 is, what was it again, 8 times 8 is, on the maths, 40, 64. Okay, anyway, it's not 8 times 8, so it's 8 times, the distance is 4, so 8 times 4 is 32, so we set the max as 32. Then we go to the next, which is j is 6. 6 is height of 3, so the distance is 5. 5 times 3 is 15, we don't increment the height. Go to next, next, which is j is 7. And so I is 1, which is 8, j is 7, which is 7. So let's move to 7, and the distance is 6. So 6 times 7 is 42. So we set this as the max, 42, and so forth. So you keep going and going and going, but this will be the biggest one because now 6 gets smaller, 2 gets smaller, so it wouldn't be any bigger than this. So 42 would be the max in this example. And so let me write the code now. So the first thing we do is we set the variable max, which we set to 0. Then we do the first for loop, which is equal to height, which I is equal to 0. I'm going to smaller than height or length. We can do -1 because j will check that value anyway. Then we do I++. Then we do the second for loop for let j is equal to I plus 1. As long as j is smaller than height or length again, then we increment j. Now, what we do now is we get the length, which is the j minus I. Then, oh sorry, what am I doing? Let length is equal to j minus I. Then we set the max to the max between current max and the length times the minimum of height I and height j. Again, this is because it's the minimum, because if it's the maximum, then it will overflow on the smaller side. And then we return the max. So this will be a brute force solution, which is of O n squared. Let's check this passes. Okay, the solution should pass, but it will fail in terms of speed. It will fail because it's too slow for the source solution. See, time limit exceeded. So this is where the next solution comes in, which is a 2-pointer solution. So let's clear this. 2-pointer solution, let me show you exactly what I mean. Well, we'll start with a left value, which is the index 0, and a right value, which is which is the length of the array -1. Then we get the current max, and we set the max to that, either the max or the current max of the array, which is again the height times the lowest value. Then if the left is smaller, we increment the left by 1, then get the max. If the right is smaller, we decrement the right and get the max of that again. So let me show you for an example on whiteboard. Let's delete all this. Okay, I should have kept the array, but okay. So 1, 4, 3, 7, and 2, and then the max right now is 0, left is 0, and right is equal to length -1. So now, we'll get the left value, which is 0, and the right value, which is 2, which is left for 1 -1, so it's 1. Right now the max is, check, the distance is 1, 2, 3, 4 wide, and the minimum height is 1, so the max would be currently set to 4. Then 1 is smaller than 2, so we increment left and we set it to 1. Now we are on 4. Let's delete this. 4. Okay, so now 4 to 2, the distance is 3. And so the smallest one is 2. So 3 times 2 is 6. The max is now 6 because it's bigger. Okay. Now 2 is smaller than 4. So you decrement the right and we set it to 7. Now the distance is 2. So 2 times 7 is 14. So we set the max to 14. Oh, I haven't got internet connection. Let's refresh. So we set the max to 14. Let me move this. Get a eraser. Max is now 14. And we was on 7, sorry. Now 7 is bigger than 4, so we move the left, we increment the left by 1. So now left is now 2. This was minus 2, sorry. And then we do 4. No, so it's from 3. So 3 to 7 is only a distance of 1. 1 times 3 is 3, we don't increment the max. And now 7 is smaller, and 3, since 3 is smaller than 7, we increment 3 to this. And as they are now the same value, it breaks the while loop. So let me do the code for you. So we get a max value. It's a bit slower there. Max is equal to 0 again. We get a left value, which is equal to 0. We get a right, which is equal to height dot length minus 1. We do a while loop. Our right is bigger than left. Continue. So first we get the height, the length of the distance pretty much. So the width of the container. So we'll do let width is equal to right minus left. Now we set the max to max is equal to math.max between the current max and the width times the min, just as before, the minimum between height left and height right. Now if height right is smaller than height left, then we decrement the right. Just want to keep the bigger value. Else we increment the left. And then we return the max. See, that should pass. It does. The time complexity is of O(n), as we only loop through the whole array once. Let's see. Oh, I lost internet connection, of course. Submit again. As you can see, it's the fastest time complexity you can possibly get. Wait, say it again. Yeah, fastest time complexity. So, yeah, thanks for watching.